So we're going to do an extra day on graphing just because I know that's always like a tough thing for people to get used to doing without a calculator. I'm going to go through and highlight the insides of each function, and we'll talk about like what kind of shape they're going to be. And then I'll give you a chance to work together, and then I'll go over it for you. So the first one, what is that parent function? All right, that's absolute value. So like what overall shape is it going to be? It'll be a V shape, and this is the part that's inside, because that's what's inside the absolute value. And you can write down the transformations on here. I didn't put that on here as a requirement, but you can certainly write them as well. All right, what is number 2? Good, so that's gonna look like what? Steps, that's it, it's like nickname is the step graph. And this is the part that's inside the function. Those ones are really good for seeing the stretches and shrinks. So remember, if it's a vertical stretch, the steps will actually be further apart from each other. If it's a horizontal stretch, the steps themselves will be longer. All right, what is number 3 called? Good, quadratic, that's going to be a U shape. And this is the part that's inside the function, all of that, because all of that is within the parentheses being squared. So you're going to have a horizontal stretch or shrink in that one. And you can always make an XY table to plot your points. And when I go over this, that's probably what I'll do for that one, is I'll make an XY table and plot some points. What do I get when I plug in 1? What do I get when I plug in 2? You can plug in whatever you want, and if it doesn't turn out pleasant, pick something else. All right, this one is square root, so everything within the square root is inside the function. The stuff stuffed inside. And that's the one that kind of like looks like a hill. Like it's half of a parabola on its side. All right, what is number 5 called? Good, that's cubic, that's the wiggly one. Right side up, wiggly one. And this is the part that's inside. I'm just trying to go through the basics of that to help you see what's inside and what's out. The 6 is cube root. That's the one that's sideways. If you want to think like roots of a tree grow out sideways. And this is the part that is inside, that x plus 6, the part that's inside the cube root. All right, and then on the back. This one is rational. Remember ratio, a fraction. So that x minus 5 is inside, the plus 3 is outside. I'm not picky about points for that one, so don't worry about making like an XY table for that. As long as you get the asymptotes in the right place and then just draw in the graph. So that one, like a little less picky about that because those graphs are kind of complicated. This one's linear. So if you want to think about what's inside the function, there's really nothing. It's just this x. I would almost just think of that more as y equals mx plus b. Like see where your y-intercept is and then do a slope. But what's going on is there is a vertical shift and then a vertical shrink as well. But if you want to think of that as just y equals mx plus b, then that's good. All right, what is number 9 called? Exponential, it's going to be a swoop. And this is the part inside the function. The 2 does not cause a transformation. That's just the base number. There has to be a value there to take to the power of. And then logarithmic, everything inside the logarithm is what's inside. That's going to be a swoop that's kind of on its side. And then we've got sine and cosine, the waves. So sine of x, we don't have anything inside of that one. Just sine of x. Actually, I didn't put anything inside of either of these just to make them a little bit less complicated. All right, so look, I'm going to give you some time to try this, and I encourage you to talk to each other. Here's your pep talk. It's not going to go well at first, so don't expect it to. Do you understand? Like it's new to you doing this without a calculator. That's why I'm giving a whole extra day for it. It's going to go poorly. But what's important is that you persevere through it, and then in the future, we'll continue to get better. Okay, that's my pep talk for you. If you get stuck on one of them, move on to the next. I'm going to give you all the answers. You're going to leave here with it completely filled out and all your questions answered. Okay. All I really want for you to do is try and work together. Okay. So I'm going to stop talking. You guys give it a shot. And then at the end, I will go over all of them for you. All right. So the first one, it went left 1. So from the origin, we're going to go left 1 and put a point. That's going to be the center of the V shape. And because both sides of the V are linear, you can use that -2 as your slope. So from that point, I'm going to go down 2 over 1, and then you can just continue that pattern. Anything that's linear, you can just use a slope. So this is our absolute value graph. If you didn't like that, I didn't like that, Ms. Cole. Make an XY table and start plugging in numbers. What do I get when I plug in 1? What do I get when I plug in 2? You know, you can do that. I think when you can use a slope, it's a little bit faster to do it that way, a little bit more convenient, but it will work. And there are ones on here I'm going to make a table for. All right, this one moved left 1 and down 3. So we're going to go left 1, down 3, put a point. And that is where your first step is. Now, how far away are the steps going to be from each other? Good. Vertical stretch by 2. So they're going to be 2 units apart. So it's a staircase that would give you a little bit more of a workout. The vertical stretch by 2. Those ones are good for seeing the stretches and shrinks. All right, this one we said is going to be a parabola. It went right 2, and then what else? Right 2, up 1. All right, so from the origin, you're going to go right 2 and up 1. That's the center point. Now, I can't do what I did with the absolute value and use a slope because the sides of a U shape aren't linear. So instead, I'm going to make an XY table and plug in some points. Now, you can plug in whatever you want, but you want to like make a good guess about what to plug in. If we have this center point at 2, let's plug in a number next to 2. Does that make sense? All right, so I'm going to plug in 1. And in fact, 1 and 3, those are the 2 points on either side of 2. Those are going to give you the same thing because it's symmetric. It's a U shape. So when we do one of these, it's like a 2-for-1 deal. Buy one, get one. All right, here's what you've got to be able to do without a calculator. We're going to plug in 1. Are you ready? 1 minus 2. That's -1 times 2. -2 squared, little tricky. -2 squared, +4, good, +1, 5. That's what you've got to be able to do without a calculator, is plug a number in and do the adding, subtracting, multiplying, dividing. So we get 1, 5, and we get 3, 5. And if you're like, hey, wow, that graph is really narrow. Yeah, because of that 2 in there. It got horizontally shrunk. It got compressed in this way. So it made it narrower. I always think those graphs look like a reindeer though. And once you see it, it's almost like you can't unsee it. This is his nose and these are his eyes. And then these are his antlers. Anybody else see that? I don't know. Like once you see it one time, like you can't unsee it with the parabolas. All right, square root graph looks like a little hill. This one moved up 2. So we're going to go up 2 and put a point. And then I want a few more points. So I'm going to make a table. Now, this is a situation where it's going to maybe take us a minute to find a good number. Like you're going to plug in stuff and it's not really going to work out. First of all, we're going to multiply it by a half. So you're going to want to pick an even number. So what's a number you guys want to try? Let's try, well, not 4, but let's try -4. Why would I want to do -4? Because the negatives cancel. All right. So if we plug in -4, negatives cancel. Half of 4 is 2. Square root of 2 without a calculator. We don't want to do that. Square root of 2 is not going to turn out nice. So let's try something else. -4 wasn't good. What's another negative number we could do? Half of 6 is 3, and I don't want to square root 3 without a calculator either. So let's try again. I told you it was going to take a few tries. 8. Good. Let's do -8. Negatives cancel. Half of 8. Hallelujah, that's a perfect square. Square root of 4 is 2, and then 2 plus 2, 4. So negative 8, 4. And usually I say let's do, 3 points, but, or actually, could we do another one? Oh, you know what? There is another one that we could do that would turn out nice. Yeah, but smaller, like that'll show up on the grid. Let's do negative 2. Negatives would cancel. Half of 2 is 1, and the square root of 1 is 1. Good. And then plus 2 will be 3. So negative 2, 3. Who said that? Negative 2? Nice job. Because I was looking at that and I was like, we should be able to get another point. All right, number 5, cubic graph. It moved right 2. So from the origin, you're going to go right 2. And now I want some more points. If you don't like drawing the table, if you're like, no, I can do it in my head. Some people like have a calculator in their brain. That's fine. I'm just going to write it down. So I have that center point at 2. I'm going to pick numbers around 2. You can plug in whatever you want, but you want to pick something close to that center point. All right, so let's try 1. 1 minus 2 be negative 1. Negative 1 cubed is negative 1. Negative 1 times negative a fourth would be positive a fourth. I'm not sure I want to plot that. Let's go a little bit further and see what else we get here. If we plug in 3, 3 minus 2 would be 1. Cubed would be 1. Yeah, that'd be negative 1/4. I don't want to plot those though. Let's try another number. Let's go like out a little bit further. Let's try, well, I don't know if I want to go that far. Let's try 0. Let's try 0 and 4. That would be like one further out. All right, let's try 0. 0 minus 2. All right, negative 2 cubed, really tricky. I want to see if you guys know that. Negative 2 cubed. A little lower, negative 8. Good, there we go. Negative 8 times negative a fourth. Negatives would cancel. A fourth of 8 is 2. Good, and then this one would be negative 2 because of the symmetry. All right, there, that's a little bit better. I don't want to plot those fourths. All right, so we get 0, 2, and 4, negative 2. Do you see how I had to like pick a few numbers and then try again? I tell my son that all the time. I'm like, you need to do try again. If it doesn't work the first time, then you got to try something else. All right, cube root is going to be on its side. It went left 6, and then what else? Down 2. All right, from the origin, you're going to go left 6, down 2. And then I want to plug in some other numbers. Now our center is at negative 6. So you would want to pick numbers near and around negative 6. Are you following me there? Like you can plug in whatever you want, but if that's the center, pick numbers near that. So around negative 6, we would have negative 5 and negative 7. So let's do negative 5. Negative 5 plus 6 be 1. Cube root of 1, 1. 1 times 3, 3. And then 3 minus 2 is 1. Again, that's what you have to be able to do without a calculator, is that adding, subtracting, multiplying. All right, negative 7 plus 6, that would be negative 1. Cube root that, you get negative 1 times 3. Negative 3 minus 2 will be negative 5. So we'll plot those, and then we're good. Now it looks like it's in a line, but you just remember it's cube root, so you have to know it's gonna do something like that. All right, 7 is rational. You actually kind of get a break with these. The graphs are more complicated, but I'm less picky about them. If you guys tell me how it shifted, we'll be able to graph it real quick. How did this one get moved? Up 3? Good. You're going to go up 3 and dot that in. And then right 5 and dot that in. And this graph did not get stretched or shrunk or reflected or anything else. So you can just go ahead and draw it in like usual. In a way, that's honestly, that was an easier one in my opinion. Yes, no, I don't know. Like the graph itself is more complicated, but I feel like it's easier to draw because as long as you get the asymptotes in the right spot, then you're good. All right, this one, I would just do it as y equals mx plus b. You're going to go down 2. And then your slope is a 4th. So up 1 over 4. Did that one go okay? Yeah, that one was good. All right, this one is exponential. It is a swoop. I like acting that one out. It moves which direction? Good, down 3. All right, so go down 3, and we're going to dot that in. There's a horizontal asymptote. Don't fade out on me. We're almost done. Pep talk. Stay with me. You do need to know how to draw graphs. All right, and then I would do an XY table. What do you want to try to plug in? It didn't shift left or right, so we're still kind of in the center. So what would be a good number to start with? Good, let's start with 0. You can't negative a 0, it's going to be 0. 2 to the 0. Good, remembered from last class, nice. 1 minus 3, negative 2. What's another good number we could plug in? Like something that's going to turn out pleasantly. That would be 2 to the negative 2. I want to do that. 2 to the negative 1. I don't want to do that either. There we go. We did one like this last class. Remember that? You're going to have to plug in negative numbers to get them to cancel. So if you plug in negative 1, negatives cancel. 2 to the 1, 2 minus 3, negative 1. And if you plug in negative 2, negatives cancel. 2 squared is 4, minus 3 is 1. Now, when you plot these, you're going to get a swoop. It's going to swoop downwards instead of upwards. That's because of the negative, because of the reflection. So it's going to look like an L. Right, logarithmic is like a sideways swoop. Instead of a horizontal, it's going to have a vertical asymptote. This one went left 4. So we're going to go left 4, dot that in. Now, we're going to do a whole unit on exponential and logarithmic later. For right now, there's really only one point that I want you to know how to do without a calculator. ln, or sorry, we haven't talked about ln yet. Forget I said that. I'm like, my brain's in calculus land. Any log of 1 is going to equal 0. Like log base 2 of 1 is going to equal 0. Log of 1 is going to equal 0. Log base 10. Log base 3 of 1 is going to equal 0. It doesn't matter. If you plug in 1, you're going to get 0. That's the only one I want you to know for right now without a calculator. So what value would we plug in order, well, because see, we got that plus 4. Now that's going to give us 0. Good. We would plug in negative 3. If you're like, hey, I didn't quite get why that is. Hold on, I'm going to talk you through it. If you plug in negative 3 plus 4 is 1, and then log of 1 is 0. So, and then times a negative would just still be 0. Any log of 1 is 0. Now, is this one going to be increasing or decreasing? Well, there's a negative out front, so it's going to decrease. It's going to do something like this. The logarithmic ones are one of the hardest ones. If you were like, hey, that was kind of a lot, don't worry. Right now, I just want you to basically know the shape. If you knew that it moved right 4, I was happy. Okay. Like I went over it for you, but I wouldn't put one like that on the test. Does that make sense? Like I showed it to you, but it wouldn't be on the test. All right, and then same with these ones. I'm showing them to you now. We're gonna do a whole unit on these later, but I'm just trying to get you used to the shape of them now. Where does sine start? If you know that at this point, I'm happy. Where's the like starting point? Origin, perfect. All right, so this one moved up 2. So instead of starting at the origin, we're gonna go up 2, and then that's where the wave starts. So from there, you're gonna go up, come back to the center, go down, come back to the center. And I'm not grading your artwork. Make an attempt to make it a nice smooth wave. Just as long as it doesn't look like a jack-o'-lantern mouth. Don't like make it all jaggedy. And then I threw you for a loop on this last one because it's reflected. Again, if you know where cosine starts at this point, I'm pleased with that. That's good. We're still going to go over it in class. I'm not going to put it on the test. Okay. Where does cosine start? 1. So yeah, like up 1 sort of, so 0, 1. So this one, instead of starting here, it's going to get reflected down to here. Watch me point to it. Instead of starting here, it's going to get reflected down to here, but then it also moved down 1 more on top of that. So it's going to start here and then wave. And again, if that was like messing with you, we're going to do a whole unit on it later. Right now, I'm just trying to get you used to the overall shapes of all the graphs. You know, like basically where they start and some of the transformations, then you're good. Ones that I would put on a quiz or test would be more like the cubic graph, the absolute value, the exponential. I would not put a logarithm on there. Like we're doing them in class, but I wouldn't put them on a quiz or test. That makes sense? Okay. Let me stop the recording.